Okay, we're going to graph the basic reciprocal function, y equals 1 over x. And as you can see, I already have a table of values here, and we'll start in the safer area of that table, which are the positive x values. So a reciprocal, of course, is flipping a number upside down, or more specifically, 1 over that number. So if we input 1 into this function as an x value, this is going to be 1 over 2. So when x is 2, y equals 1 over 2. When x is 1, y equals 1 over 1, which of course is the same. And the reciprocal of a half is 1 over a half, which flips that upside down to be 2. And of course, we have a problem right here. When x equals 0, this is going to be 1 divided by 0, which in mathematics, as we've seen a few times before, this is undefined. Nothing useful can be assigned to the quantity 1 divided by 0. So that means our function will not exist at x equals 0. And what that means is we'll have a dotted line right at x equals 0 that'll show, and hopefully this dotted line is straight on your paper when you're sketching this. This dotted line is showing that our function is not continuous there. There's a break in our function, and you'll see that in a little bit better detail in a few more minutes. And this dotted line where the division by 0 occurred is called a vertical asymptote. Okay, so let's maybe plot those other points that we already have. 2 and 1/2. So when x is 2, y is a half. 1 and 1. And when x is a half, y is 2. Probably use our imagination. If we kept putting in 3 and 4, we'd be getting reciprocals of those numbers, and the bigger the number gets, the smaller the reciprocal gets. So maybe we could just, without a table of values, go roughly a third and a quarter and a fifth, etc. And the closer we get to, I guess the smaller our x values get, the bigger the reciprocal gets. So if I put a third in here, that'll jump up to 3. And if I put a quarter in here, that'll jump up to 4 over 1, etc. And we can start to see what this function is going to look like. Now bear with me here as I try to sketch this on the tablet. Easier said than done. Hopefully yours is a little straighter than this. And I think what I'm going to do is just do it piece by piece here. So this should be a nice smooth continuous line, which of course doesn't really materialize on the tablet. Okay, so there's supposed to be a nice smooth branch to our basic reciprocal function. Okay, so now let's finish off our table of values and those negative values. So maybe we'll start at -2. The reciprocal of -2, of course, is 1 over -2. So as you can see, that is simply going to be -1/2. So negatives stay negative and positives stay positive when you take the reciprocals. And similarly, 1 over -1 is going to be -1. And the reciprocal of -1/2 is going to be -2. So we can plot those points in our graph paper over here. So at -1/2, we have -2. And at -1, we also have -1. And at -2, -1/2. And we can see we basically have the mirror image of that first quadrant piece now in the third quadrant. And similarly, as we go farther and farther from the y-axis, the reciprocals of these numbers get closer and closer to 0. And the closer we get to the y-axis, the bigger these reciprocals get. So if you want to visualize something specific there, put a -1/3 in, that goes to -3, a -1/4 to -4, etc. And I'll try to somewhat connect these smoothly. This one's going a little bit better than the first branch. So maybe we'll have a look at this function on our GDCs in a few minutes too, so you can actually see what it's supposed to look like. Okay, so we have a vertical asymptote there. Of course, that was located where we had division by 0. And as you're probably also noting, this function can't cross the x-axis. So we have another asymptote. And luckily, and of course that should have been a perfectly straight dotted line there, which it's not. This is a horizontal line, so of course we call this a horizontal asymptote. And just a little bit about that word asymptote. It's a little tricky to spell the first few times. There's a lot of consonants in there. but basically means it does not touch or will never meet. So this function gets closer and closer and closer to its horizontal asymptote as it goes far right, as x values go far right and far left, but it never actually can touch that horizontal asymptote. And the significance is this function can never output exactly 0. It can get really close to 0, but it doesn't output exactly 0. Similarly, with the vertical asymptote, as we try to input a 0, the closer we get to 0, the bigger the numbers get, or the smaller those outputs get, depending on whether we're inputting small positive quantities or small negative quantities. So that's I guess a quick look at our reciprocal function. If that was a paper 1 setting, you can probably sketch that in a hurry. One thing we should do before we finish off, is have a look at our graphing calculator, and we'll have a look at that function and explore the asymptotes a little bit more here whenever this loads. Okay, so here we go. 1 over x, our function, and our function input. And there it is. And it's not crooked, it's actually nice and smooth. And if we turn on our trace feature here, graph trace, we can see we have some issues if we try to input x equals 0, our function is undefined, and of course that's our vertical asymptote. And if I just walk with my arrow keys through some positive x values, we can see if I get close to the y-axis, the values get big in a hurry. And if I put in a small positive quantity, like 0.1, that goes to 10 after we take the reciprocal, 100th becomes 100, etc. So we can start to see that function skyrocketing towards its vertical asymptote. And now on the other side, if I can get this to back on the screen, if we go far right with x values like 10, we can see the reciprocal gets smaller and smaller and smaller. Okay, so maybe we'll go back to 0 again. And on the left hand, the negative branch, I guess we can call it, is basically the same stuff, except of course we're going straight down. So if I look at negative 0.1, or is that negative 0.01, I guess we might as well jump right to that. That is negative 100th. And that will jump to negative 100, and our function is going absolutely berserk near that division by 0. And if we go far left, notice we are approaching that horizontal asymptote from underneath, but the same principle applies. We can only get closer and closer and closer to an output of 0, but we can never actually get to 0. And if I keep exaggerating this here, now keep in mind, if I keep adding some zeros, yeah, even our graphing calculator is pretty, has lots of memory here. A lot of calculators would start to output 0 at this point, but we still have some wiggle room there left yet as well. So keep in mind, oops, if I can get that tamed down, when you sketch a reciprocal function, a basic reciprocal function, I can shut that trace off. You really should show a couple of points on either branch, 1 or 2 on either branch, and most importantly, have both of those asymptotes clearly visible on your sketch/graph.